Hello, everybody. We are ready to start section 10.3a. We're going to do operations with radical expressions. We're actually just going to stick to adding and subtracting radical expressions. This may feel like a review because we're going to do some breaking down. I'm going to ask you what perfect squares go into that, blah, 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 all the stuff that we did in section 10.2. So first of all, we need to mention that like radicals mean that we've got the same radicand. Radicand, remember, is the number out in front, or sorry, the number underneath the square root sign. If it was a cubed root sign, we'd have the same radicand. We haven't worked with cubed roots, but we could have like radicals. And we're going to use exactly the same method to combine like terms that we used for monomials. So this example down below here with the little bracket, I've got a 3x plus a 6x. If I gave you that, everybody would know what to do, right? You tell me, oh, it's an easy answer, Mrs. Stauffer, that's a 9x. Well, I'm telling you, you're going to use the same thing. You're going to keep your x's the same, and you're going to add the numbers out in front. So if I give you a 3 square roots of 2 plus a 6 square roots of 2, you're going to say, oh, that's really easy, Mrs. Stauffer. I'm just going to add the 3 and the 6, and I'm going to get a 9, and then I keep that square root of 2 exactly the same, just like I did when I was using x's. So same methods, add the coefficients, keep the radicand and the radical all the same. So to add and subtract these guys, combine your coefficients of your like terms, just like we just said. We combined the 3 and the 6. And don't do anything with your radical. Don't do anything with your radicand. Sometimes on that last problem, somebody might want to tell me that 6 square roots of 4. And that would be if we were timesing them. When we multiplied, remember, we multiplied the under the radicand stuff. So leave the radical, leave the radicand alone. Don't do anything with that. So let's do a quick example. I should have put the examples right on the same screen here. So for example, 1a, I've got a 4 plus a 3 square roots of 7 plus 6 plus 5 square roots of 7. I see two pairs of like terms. One pair of like terms have radicals. One pair of like terms don't have anything on them. So do you see the square roots of 7? I've got 3 square roots of 7 plus 5 square roots of 7. If we combine those the same way that we combine variables, I am looking at 8 square roots of 7. My other pair of like terms are nice and easy. A 4 plus a 6, so everybody's going to tell me that we've got a 10. I usually write it as 10 plus 8 square roots of 7, but you could write it the other way as well. Please don't answer the phone. It's not really ringing. Letter B, we've got 7 square roots of 3 minus 3 square roots of 6. Do we have like radicands? So can we do anything with this? We can't do anything with the 7 and the 3 because these two numbers right here don't match. They're not like terms, which means we can say we can't combine, or it's in simplest form, or we just rewrite that because that's as combined as it can be. Letter C, I threw a little strange looking problem at you, but tell me, does the radical stuff all look the same? We've got the little tiny 3 out in the inside of the crook of that radical house. We've got an xy, both as our radicands. So even though we haven't worked with any cubed roots of anything, I can still combine my 8 and my 14 for a 22. I'm going to leave the radical and the radicand alone. So those can still be combined. So those are the simple ones. They're just shouting at you, right? You can see that you've got square roots of 7s, or you can see that they don't match. Now, we may have to do some simplifying, because sometimes I'm not going to give you the matching. I'm going to make you work to find the matching radicands. So check out every single radical and simplify. So that's where I would ask you, what perfect square goes into that number? Once you do that, then look for your like terms. It's like a puzzle. Which ones are going to end up being the same? So you know I like to make you do some work to do some work. So we're going to have to do some work for this. So let's do letter A, 2A. It says to add or subtract. We've got both in our problem. That's fine. I've got a square root of 50 plus 3 square roots of 32 minus 5 square roots of 18. Well, I don't have any like terms because my radicands are 50, 32, and 18. However, I am telling you that I could break down all three of those terms. So 50 is not a perfect square, but is there a perfect square that goes into 50? Everybody's telling me that's 25 times 2, right? Which one's a perfect square? What is its square root? So how does 5 square roots of 2 look for that first term instead of a square root of 50? 32, is 32 a perfect square? But does it have a square root that goes into it? That would be 16 times 2, right? Which one's a perfect square? What is its square root? So I would, oh, and this is where I have to ask the question. I should have circled this right at the start. What am I going to do with the 3 that I already had and the 4 that I just got? I'm going to multiply them. Is that 12 a positive or a negative? What sign am I using here? That's positive. And then I do have a square root of 2 left. How about an 18? Is an 18 a perfect square? Does a perfect square go into 18? That's just shouting out 9 and 2, right? I'm going to circle that 5 there too. Which one's a perfect square? What's its square root? What am I going to do with that 3 that I just got and the negative 5 that are, or the minus 5 that was already sitting out in front of the radical? Multiply those guys and I've got a minus 15 with a square root of 2. Now, how many like terms do I have since I did all that work in order to finish the problem? All 3 of those guys are square roots of 2's. So I'm just going to do the math with a 5 plus 12 minus 15. If I did my math right, I think that's going to be 2. And then I leave the radicand and the radical alone. I just bring that down as the square root of 2. If that were a 5x plus a 12x minus 15x, you would tell me it's 2x. You wouldn't do anything besides add the coefficients. Let's go over to D. So D, I've got a square root of 24 minus a square root of 54 plus a square root of 96. Let's do this nice and easy. So 24, not a perfect square. What perfect square goes into it? I think that's just going to be a 4 times 6, right? So does everybody agree with 2 square roots of 6? How about 54? Definitely not a perfect square. I believe that one's going to be 9 times 6. So how does a 3 square roots of 6 look? What sign am I putting in front of that 3 square roots of 6? Don't forget that minus sign. And 96, that's an ugly one, but let's see, I believe that's going to be 16 times 6. Check your calculator, make sure that I'm doing my math right, because you know me. 4 with a square root of 6, and that one's going to be a plus. So now I'm ready to combine my like terms. That work paid off. I've got all 3 of these are square roots of 6. Which means that I can just add my coefficient with a square root of 6. So how many square roots of 6 should I have for my answer? I'm going with a 3 because 2 minus 3 plus 4 gives me a 3 square roots of 6. This should feel very much like what we did before. We're just adding the combining at the end. So, unless you want me to talk some more, I'm going to ask you, how do you combine like terms when you're working with radicals? For example, 5 square roots of 7 minus 15 square roots of 7. Explain to me in words. What do you do? And practice problem. Oh, there we go. Do that problem. I would try 25 for the first one when you break it down, and probably a 16 for the second one. So those of you who don't listen to the sound just missed out on a big clue. We'll see you next time. Have a great day.